Good day, everyone. It's another day and another lesson to learn. Welcome to another session of Ease Class. In this video, we are going to discuss about measures of variation, part 1. At the end of this video, you will be able to determine the statistical tools of measures of variations, solve problems involving measures of variations, and interpret the result of the computed measures. Measures of variability or measures of variation is also known as measures of dispersion, which means it indicates the degree to which numerical values are dispersed or spread out about the mean. This would also tell us if the data is homogeneous or heterogeneous. So take note, class, that in our previous discussion, we discussed about measures of central tendency and its relationship to measures of dispersion. It is also very important to identify the central tendency to meaningfully interpret the results. These are the statistical tools under measures of variation: range, average or mean deviation, semi-interquartile range, quartile range, variance, and standard deviation. Let's start with range. Range is the simplest to compute. It is the difference between the largest and the smallest values. So these are the formulas for the ungrouped data and group data. Ungrouped data, range is equal to highest value minus lowest value, while for group data, range is equal to upper boundary of the highest class minus lower boundary of the lowest class. Example: for ungrouped data, you need to identify the highest and the lowest value, substitute it to the formula, and compute the range. So these are the values: 2, 4, 5, 7, 10, and 6. What is the lowest value? It is 2. And the highest value is 10. Therefore, we will substitute to the formula, which is R is equal to HV minus LV. So that is 10 minus 2, which is equal to 8. Next, for group data, here we need to identify the upper class interval of the highest class and the lower class interval of the highest class. Substitute to the formula and compute the range. So take note that this is your lower class interval, and that is the lowest, while this one is your UCL, or the upper class interval of the highest class. So in that case, substitute it to the formula. That would give you 20 minus 5 is equal to 15. Therefore, the range is 15. Let's move forward to mean average deviation. It is more reliable measure of variation than the range, the interquartile range and semi-interquartile range. It is the average of the absolute deviations of the individual values of a set of numerical data from either the mean, the median, and the mode. Let's have a review. Take note that in this video, we will be encountering the symbol for absolute value. The two lines indicates the symbol of absolute value, and that is an absolute value symbol, which any number inside that symbol is equal to a positive number. Example: if you have an absolute value of negative 5, that's always equal to 5. If you also have an absolute value of 5, that's also still equal to 5. Any number will be changed to a positive number. Okay, let's have the formula. The formula for ungrouped data is AD is equal to the summation of the absolute value of the difference of x and mean divided by n. For the group data, its AD is equal to the summation of f times the absolute value of the difference of x and the mean divided by n, where x refers to the individual value of the ungrouped data and the midpoint of each class interval for group data, while the x bar is the mean data, n is the total number of frequencies, and f is the frequency of the class interval. Let's have an example. Let's start with the ungrouped data. Consider the math test score of Anna. Find the average deviation of the score 14, 12, 20, 21. In this case, first step is to arrange the values from highest to lowest or vice versa. Then compute the values of the mean. Next is find the individual absolute value of each deviation from the mean. 4 is find the absolute value in step 3 and substitute the values in the formula and solve. To do that one, we have to start with step 1. Arrange the values from highest to lowest or vice versa. In our case, we started from 12, 14, 20, and 21. There are 4 scores in all. Next to that is to solve for the mean. To solve for the mean, you just have to add them all and divide it to the number of cases or scores. That is 12 plus 14 plus 20 plus 21 divided by 4. That is 16.75. After that, we will find the individual absolute value. To do that one, example is let's have the x minus the mean, which is 16.75, and that would be equal to negative 4.75. Okay, and take note that you will get the absolute value of that. That's why it's become 4.75. So in other words, your column would have x, x minus mean, and absolute value of x minus mean. So let's have another example. Let's have 14 minus the mean, which is 16.75, is equal to negative 2.75. Absolute value of negative 2.75 is 2.75. Just do the same thing to the other scores. Another one, 20 minus the mean, which is 16.75, get the absolute value, that is 3.25. Okay? Now, just continuously doing that one, you will come up with this, the summation of the absolute value of x minus mean. Again, this is the summation, meaning after you'll be able to identify the individual absolute value, you will add them up to get the summation of it. So just substitute to the formula, that is summation of x minus mean bar is equal to 15 divided by 4 is 3.75. Therefore, your mean absolute deviation is 3.75. Next, group data. Calculate the mean median of the scores obtained by students in the first quarterly examination. There are also 5 easy steps to do that. Let's say these are the, the results, but we will solve them individually. Step number 1, compute the mean of the distribution. I will not be discussing anymore how to compute the mean of a group data because we're already done talking about it. But to give you a glimpse of it, to solve for the mean, you will have summation of fx divided by n. First, you will be adding all the values of f, that is n is equal to 90. Then, to get the mean, you have to get the summation of fx, meaning you get the class mark, which is the center of 41 to 45, 46 to 50, and all the other CI or class intervals. Multiply them. 5 times 43 is 215. 10 times 48 is 430. 18 times 53 is 954. Just do the same thing until you can come up with the summation of fx, which is 5,220. Then divide it to the number of cases or scores in all, that is 90. So 5,220 divided by 90 is 58. That is now your mean. Next to that is we will have this column, the x minus mean, the absolute value of x minus mean column. To do this one, to get this, you will have 43 minus 58, and the absolute value of that is 15. Next, 48 minus 58 is equal to negative 10. Absolute value of that is 10. 53 minus 58 is negative 5. Absolute value of negative 5 is 5. 58 minus 58 is 0. 63 minus 58 is positive 5. Absolute value of positive 5 is still positive 5. 68 minus 58 is positive 10. Absolute value of positive 10 is still positive 10. 73 minus 58 is 15. Absolute value of 15 is still 15. Next to that is we will add another column, the f times the absolute value of x minus mean column. To do that, you will just multiply f to this column. F to the absolute value of x minus mean column. That would give you 5 times 15 is 17. 10 times 10 is 100. 18 times 5 is 90. 25 times 0 is 0. 17 times 5 is 85. 9 times 10 is 90. 6 times 15 is 90. After that, we will get the summation of this column. So, the summation of f times the absolute value of x minus mean is equal to 530. Next to that is we will solve the MD or AD. To do that one, just substitute it to the formula. That would give you 530 divided by 90 is equal to 5.9. Therefore, your average deviation or mean average deviation is 5.9. Next, let's proceed to interquartile range. It is found by finding the difference between the values of the third quartile and the first quartile. In this case, we need to unlock our knowledge from the previous lesson, which is identifying the third quartile and the first quartile. So take note that the formula for interquartile range is IQR is equal to Q sub 3 or third quartile minus Q sub 1 or first quartile. Since you know already how to locate the third and the first quartile, then it would be easier for you to solve the interquartile range. In this case, we have 4 easy steps to follow. First, solve the third quartile and the first quartile position. Second, locate the third and the first quartile. Third, substitute to the formula. And fourth, perform the indicated operation. Step 1. Solve the third and the first quartile. To do that one, we will use the formula Q sub K is equal to Kn divided by 4. So in this case, your K is 1 and N is 8 because there are 8 scores in all. That would give you 2. Therefore, Q sub 1 is in the second position. 1, 2, therefore, Q sub 1 is 4. Next, to solve for Q sub 3 or third quartile. That is third quartile is equal to 3 times 8, which is the number of cases or number of scores, divided by 4 is equal to 6. Therefore, Q sub 3 or third quartile is in the sixth position. 1, 2, 3, 4, 5, 6. Therefore, third quartile is 13. Take note, class, that you have to arrange the scores in ascending order. Let's proceed to solving the IQR. IQR is equal to Q sub 3 minus Q sub 1. 13 minus 4 is equal to 9. 13 is your third quartile and 4 is the first quartile. Subtract them, which will give you 9. Therefore, the IQR is 9. Let's proceed to the group data. IQR is equal to Q sub 3 minus Q sub 1, or third quartile minus first quartile. Take note that you know already how to solve the third quartile and first quartile of a group data. Therefore, it would be easier for you to solve the interquartile range. There are only three easy steps to follow. First, calculate the third and the first quartile using the steps we had in the previous lesson. Step 2, substitute to the formula, and step 3, perform the indicated operations. Hypothetically, we're able to solve already the first quartile and third quartile, 46.75 and 53.06 respectively. Now, we will be substituting it to the given formula. IQR is equal to 53.06, which is the third quartile, minus 46.75, which is the first quartile. That would give you 6.31. Therefore, the IQR for the given set of data is 6.31. Next, semi-interquartile range. It is found by finding the difference between the values of the third quartile and the first quartile, then the result will be divided by 2. So this is just getting the interquartile range, but you divide it by 2 after. So let's have an example. Let's say the scores are 2, 4, 5, 7, 9, 13, 14, and 17. We will be following the four easy steps. First, solve the third quartile and the first quartile position. Second, locate the third and the first quartile. Third, substitute to the formula. And fourth, perform the indicated operation. Let's start with Q sub 1, or the first quartile. First quartile is equal to 1 times 8 divided by 4 is 2. The second position is 4, therefore Q sub 1 is 4. Next, Q sub 3 is equal to 3 times 8 divided by 4 is 6. Now locate the sixth position, 1, 2, 3, 4, 5, 6, and it's 13. Therefore, just use the formula as IQR is equal to Q sub 3 minus Q sub 1 divided by 2, which is 13 minus 4 divided by 2. And after dividing 9 divided by 2, that would give you 4.5. Therefore, the SIQR of the given set of data is 4.5. Next, let's have the group data. SIQR is equal to Q sub 3 minus Q sub 1 divided by 2. We will just be following the same steps. To do that one, you need to identify the first quartile and third quartile. Again, you review on how to calculate the third and the first quartile in group data. Q sub 1 is equal to 4.67 and Q sub 3 is equal to 53.06. Substitute it to the given formula, 53.06 minus 46.75 divided by 2. That would give you 3.15. And 3.15 is the SIQR. Class, you can also round it off to the nearest hundredths. So meaning it can be answered by 3.15. Okay, so this is your time to have your exercise. Solve the range, mean average deviation, interquartile range, and semi-interquartile range of the given set of data for the ungrouped data and the group data. Thank you very much, everyone, and have a good day.